Now this is a continuation on from the typecasting module, and what I want to show you is a few handy tools that we have within the Java language, stuff that's already been built for us, some really great actions that we could take advantage of. Now in the previous module we showed that we could typecast from one numeric type to another numeric type, but the problem was that we had to deal with truncation. We would lose all of our decimal places if we did that. So the solution was to add 0.5 onto the number and then typecast, and it would work just fine. But of course, we run into the problem, what if you're dealing with a negative number? Then you have to subtract 0.5. Of course, then you have to know whether you're dealing with a positive or negative number. This, of course, can lead to some issues later on down the line, and we don't even know how to do it at this point because we haven't got to that point yet to decide whether or to make decisions in our program. So for right now, we're going to learn something else. We're going to learn a new object. Now, the only object we've got so far, for the most part, is the string object, which is a data type. The next object I'm going to teach you is a library full of attributes and behaviors called the MathLibrary, or the math object, depending on how you want to word it. But basically, it's full of data and it's full of actions that we can perform. The main piece of the main action we're looking for right now is if I have, for example, an integer, let's say, or sorry, a double. Let's say double num. We're going to set that equal to 3.7. Now, if we typecast that and just said, let's say an int num2 is equal to the integer cast of num, then of course what's going to happen is it's going to cast. It's going to cast our double to an integer, but it's going to lose the 0.7. Meanwhile, we would really like it to round in most cases. But let's just quickly display what this result is. System.out.println, and we're just going to display num2. And if we run it, we see at the bottom there we get the value 3. Great, that's exactly what we're expecting. Now, if we want to actually round that, then of course we need to do the math and say, well, let's take this num and let's add on 0.5, and from here we should end up with a proper value of 4. This is great. But of course, again, this only works with positives unless I'm starting to do some checking on the value of num to see whether I should add or subtract. So what we want to do right now is we're going to do this in a completely different way. The math library has a special piece of functionality called round. It'll actually do the rounding for us, and it'll do appropriate rounding. It'll round up when it should, round down when it should. So 0.5 and above will round up. 0.4 and below, or anything less than 0.5, I should say, will round down. So if we look at this, let's say the way to do this, we first have to call the object by name, math, and then we hit the dot operator, and this tells us all the different functionality we have within the math object. And you can see there is a lot. The one we care about right at this moment is round. So I'm just going to type in round, and you can see it narrows it down. And based on those two descriptions, I can either insert a float value or a double value. Well, right now I'm going to insert a double value, which is num. Now this is fine. This will actually round 3.7 to the appropriate value. But the problem is, if I put my mouse over round, you'll see that right up at the top, let me just like this. This actually gives us back a long value, not an int, not a double. Now we haven't seen long yet, but basically integer is a 32-bit number, so it can hold big numbers between -2 billion and +2 billion, give or take. Long is a 64-bit integer, no decimals allowed, whole numbers only, but it's 64 bits, so the size of its numbers are astronomical, absolutely huge, way bigger than any integer can hold. But the problem here is that this is a long. So we can't put a long inside of an integer. A long is 64-bit, an integer is 32-bit. It just doesn't fit. Square peg, round hole. Can't put it in. So what we have to do is we actually have to use a combination of both the round and typecasting. So I'm going to typecast the result of this math.round. Now if we run it, we get our 4 again. You might think, well, why do I want to do this? Why don't I just add on the 0.5? Because we don't have to handle any logic of knowing whether our num is positive or negative. So that's the first introduction into the math library. What I want to show you right now is all the other options we have. The first option is something that you've previously seen with the constant stuff. Before, if we wanted to use pi, we would create a constant. We would say final double pi equals 3.14. Now, I don't know about you, but I'm pretty much lost after 3.14159. I can't get any precision out of that, anymore out of that, and I have to type that in to actually remember. Luckily, math already has this value for us. So if I want to use pi from the math library, I literally just type in math.pi, and there it is. And this will actually give us quite a bit larger of a number. Not huge, but quite a bit. So just to show you how big it is, let's just quickly display it. Math.pi. And if we run it, oops, we see at the bottom here, we get it to quite a few more digits than I know. So this will help us in our calculations to make sure our calculations are much more precise depending on what it is we are trying to actually calculate here. So those are that's really the main piece of data that we can get out of the math library. But now let's get into the functionality. And the functionality is great. Let's take a quick look. Right here. So I've made a list of all the common pieces of functionality that we use from the math library. We've already seen math.round. There's also math.floor, which will round down. Math.ceil, short for math.ceiling. Math.abs, which is short for absolute value. So if you don't know what an absolute value is, basically it's the positive of whatever number you have. It just removes the sign. So if you have 3.2, it's going to give you 3.2. If you have negative 3.2, it's still going to give you 3.2. And the value of math.abs is it can take either an int or a double, and it will give you the same thing back again. Math.pow, short for power or exponent. You give it a base, you give it an exponent, and it will give you the result of the exponent calculation. So here in the example, I have 2.2 to the power of 3, which results in 10.648. Math.squirt or math.square root. Square root calculation, it just is exactly what it sounds like. The square root of 9 is 3. Now here we get into some trigonometry, math.sine, math.cos, math.tan. Their inverse functions also exist, math.asine, math.acos, math.atan, which are short for arcsine, arccos, arctan, which is really just sine to the -1, that kind of stuff, the inverse function. All of that exists in there. Of course, you'll be using that if you want to build any graphical or gaming programs. Again, these ones are used for that purpose as well. Math.2radians. So another unit of measure to measure an angle, as opposed to degrees, is something called radians, which you may or may not have learned in math class yet. It's just another form of measurement. Basically, a full circle is equivalent to 2 pi. So a half a circle, 180 degrees, is equivalent to pi, as we see right here. So if we convert 180 degrees to radians, we basically get pi. Down here, I tried to do a rough 90-degree angle, so I said convert 1.6 radians to degrees, and I got 91.67 degrees. And then finally at the bottom here, math.random. We will probably not use this for the most part, but I put it in there anyway. There is better utilities in Java to get random numbers, much more accurate, much faster, and definitely much more random. So this was just here just to show you that it exists, but for the most part, we won't be using this form of random functionality, which you'll see in upcoming videos. So that's the math library, all the things we can do with it, and how we can improve our typecasting with it. Thanks.